Hello everybody, welcome to another lecture. Today we're going to talk about osteology. We're going to talk about the skeletal system. And the way we're going to do this, we're going to divide this presentation in two parts. The first part, we're going to talk about types of skeleton. We're going to talk about the types of bones and the structures inside of the bones. And the second part, we're going to talk about how bones are created, the process of ossification, how ossification takes place, the types of bone cells, and what kind of factors affect um, the process of bone remodeling. Osteology and understanding the skeletal system and understanding how the properties of bones is a very important concept to have, especially for us horseshoers, because things that we do at the bottom of the horse's foot will directly affect uh, bone structure, and directly affects, coffin bone, and it affects weight bearing, and it affects body positioning, and all of those things. So it's a very important concept to have it. So the whole idea of this presentation is just to provide with an overview, with a general understanding of osteology and the skeletal system, the anatomy and physiology involved in the skeletal system. So first of all, we have to understand what the skeleton is. And the skeleton is nothing more than a framework of structures, of hard structures, that supports and protects the soft tissues. Right? And animals can have different types of skeleton. You have animals that have the skeleton located inside of their bodies. Those are called your endoskeletons. The skeleton is inside, it's endo. Endo means inside. And you have animals that have the skeleton located outside, almost like a shell. Well, it is a shell actually. And what happens is, as these animals grow, they have to shed their exoskeleton and replace that skeleton um, with a new one that will accommodate their new size, their new body size. So we have endoskeletons inside of their bodies and exoskeletons outside of their bodies, right? For the sake of what we do, we're going to be focusing on endoskeletons, of course, because we're going to be talking mainly about the horse. Uh, So when we're talking about the endoskeleton, we can pretty much break it down. The endoskeleton, the skeleton of a horse or the skeleton of a human, in two different parts, right? One part, if you look at the skeleton uh, in a longitudinal direction, actually from cranial to caudal, we are going to see uh, the head, right? Yeah, our vertebrae, the ribs, and the sternum. Those bones, they make up what we call the axial skeleton of the horse. It defines the axis of the horse, correct? If we look at the horse in a more vertical perspective from proximal to distal, right? That's what we call the appendicular skeleton, because it make up those are the appendices of the horse. Uh, of course, the way the skeleton is set up is gonna determine the horse's conformation. So when we're looking at the way the vertebrae, the way the axial skeleton is defined, that's going to determine the top line of our horse, right? So for instance, if I have a horse that has a very very low withers and a very high croup, because this attachment here, right, between our cervicals and our thoracic vertebrae is very low, then probably this horse is not going to be a very good uh, jumper prospect, right? It's going to be fairly heavy on the forehand. So just to give an example, that the top line of the horse is defined by the axial skeleton, and the appendicular skeleton connects to to the to the axial skeleton, and later on we're going to talk about how those connections take place. The front limb connects to the skeleton differently than the hind limb. We have to understand what are the main functions of bone. Right? What do bones do for the body? First thing is support. Right? We said that the bones they support soft tissue structures. Right? So bones they work as attachment points for muscles, for tendons, for ligaments. So they support the inside structures. Protection. The bones work as shields for internal organs. For example, our rib. For example, look at the ribs. Look at the ribs. They are protecting the structures inside and between them, like the heart, the lungs, and things like that. Movement, right? Bones, some types of bones, they act as levers. Muscles will provide tendons. They will attach to bones, and as those muscles contract, those tendons will move those bones, which will cause the animal to move. Mineral storage. 99% of the calcium storage in the body is in the bones. Right? Bones store minerals like calcium, phosphorus, and depending on the body regulation, they will release those minerals into the bloodstream, or they will absorb those minerals from the bloodstream. If you have too much calcium, right, in the blood, they will absorb it, and vice versa. And they have another function called hematopoiesis, which is nothing more than the production of blood cells. You're going to see there is structures inside the bones that are responsible for producing the blood cells, to renewing the blood cells in our bodies. There are different types of bones, and those types of bones are pretty much related to their function and their ossification process, right? So we have long bones, right? Those are bones that are very elongated. They have more like a cylindrical shape, right? We're gonna see them mostly in the limbs, in the appendicular skeleton. We have the short bones, right? The long bones. One of the main features of a long bone is that they have what we call the medullary cavity. The medullary cavity is going to be, they're hollow inside. So we're going to see later on that they have a thing called medullary cavity. The short bones are bones that have pretty much the function of diffusing concussion. You're going to see those bones inside the knee, inside the hock of the horse. Now there are short bones there that they have the main function is to diminish concussion or to increase leverage to muscles and tendons. We have flat bones. They're pretty much bones that grow in two directions. Bones that we're going to find them in the skull or the scapula. Oops. We have irregular bones or vertebrae. They're a very specific type of bone. And then we have bones called the sesamoid bones, like the patella, like the proximal sesamoids or the navicular bone. When we're talking about flat bones, every bone we're going to see that they have two layers. They have an outside layer and an inside layer. An outside layer, that's what we call a compact bone, a compact substance, right? It's the hard part of the bone, right? It's basically made out of inorganic material. And the inside of the bone is called the spongy bone, which is the soft bone, which makes up for the bulk of the bone, right? The flat bones, as we can see, it's almost like a sandwich. We have the two outside layers of compact bone and an inside layer of spongy bone. Okay. Now, if you look at the structure of a long bone, it is a little bit different because, like I said, they are hollow on the inside. They have a thing called medullary cavity. This is the medullary cavity, which is also filled with a spongy bone, right? You have the outside, the cortical bone outside, and the inside, of the medullary cavity, you're going to see that we have the spongy bone. Right here you can see a very cool shot of a transverse section of a long bone, and you can really see here the cortical bone, and here you can see the cancellous bone. Okay. The long bones, we can pretty much name specific regions of the long bones because every one of these regions is going to be related to a particular function. If you look at the long bone this way, vertically, you're going to see that the ends of the bone, the extremities of the bone, they are called epiphyses, right? And then later on, we're going to see that the epiphyses are very important because uh, that's from that's directly related to the growth of the bone, how the bones are going to grow. The shaft of the bone, it's called diaphysis, right? The shaft is the diaphysis, the end of the bone is the epiphysis. And between the epiphysis and the diaphysis, there's a little region here called the metaphysis, right? There's a little line here when the bone is growing called an epiphyseal line or epiphyseal growth plate, which is nothing more like a cartilage layer that with time is going to ossify. When we look at the cancellous bone, we said that we mentioned that bones, they have two types of substances that make up the bone. The outside part, the bone cortex, which is the cortical bone or the compact bone, and the inside of the bone, that is our cancellous bone. The cancellous bone, as we can see, it looks like a huge mesh of of these little like spicules, look like almost like a web, and this all those holes, those webs are called the trabeculae, and between those holes is going to be all filled with bone marrow. Right, bone marrow will be in here, filling all those spaces, all these gaps, and the bone marrow. As we all know, we have two types of marrows. We can have the red marrow, and the yellow marrow. And the red marrow is directly related to the hematopoietic functions of the bone, or to produce the blood cells. And the yellow marrow is basically fat, adipose tissue, and then as the animal gets older, the the red marrow starts to get replaced by the start turning into yellow marrow. Uh, so we have all these spicules here, and it looks like they're organized in very unorganized fashion. But in fact, the organization of these spicules is directly related to what kind of load the bone is submitted to. Right? They're organized in a way that will allow the bone to withstand the greatest amount of pressure. Uh, they provide a little bit of flexibility to the bone. However, not flexible enough where they will bend and break, right? Because we're going to see the bones are constantly changing. Bones that can atrophy if they're not used, or they can uh, hypertrophy if they are overused or they're submitted to different load of uh, based on what kind of load they're submitted to, right? The compact bone is a very interesting structure. Is the compact bone, the outside of the bone cortex. If you look at the compact bone, here we have a little picture of a bone, and what we're doing is we are zooming that picture in. And you're going to see that the cortical bone is pretty much made out of these concentric circles. Those concentric circles are called the osteons. and they're called the osteons. And if you look at every single osteons, we have some very defined characteristics. One, you can see those little lines around, right, that they define each circle. Those lines are called the lamellae, right? And between those lines, you have all those little holes here, right? We can see all those little holes here, right? They are called the lacuna. In between those little holes, it's all interstitial tissue. And the cool thing about the compact bone is that this interstitial space, right? So interstitial means space between cells, is pretty much filled with the bone matrix. Now that is pretty much that it is hard, you know. And inside of the lacuna, that's where we're gonna find our osteocytes, the cells that are the bone cells, pretty much the cells that are providing the nutrients and they are providing the function to the bone. Okay? This whole osteon system here, it is called a Harvesian system because of, of the person that studied it. But anyways, you have an osteon, right? And inside those osteons, you're gonna have a central canal. In this central canal, that's where we're gonna have our blood vessels, our lymph vessels, our nerves, all running through that, right? And those canals, those vertical canals, are connected by perpendicular canals. They're called the Volkmann's channels. These are the Volkmann's channels here, and here you have our central canal, right? And you can see here how those circles they are connected by those little tiny bitty paths here. Those are called canaliculi. So each lacuna connects to another lacuna to those canaliculi, and in the middle of each osteon we would have the central canal that connects to another osteon through the Volkmann's canal. So it is a it looks almost like we have cut a tree, and it's like a tree stump. It's the very exact same appearance, right? And if you look at those bones, on the outside of the bone, there is a little layer there. That's what we call the periosteum, right? The periosteum can pretty much be divided in two different layers. The outer layer, which is just protection, and the inside layer, which be a layer that will create the bone cells that will migrate inside, right? Uh, Between our cortical bone here and our cancellous bone here, you'd have another layer here called the endosteum. So if you look at this picture, the endosteum would be right in here. If I go back to the picture where I have my long bone, my endosteum would be somewhere around here, this section right here. The endosteum would be about this line right in here. Okay, so this is pretty much the structure of a compact bone. Like we said, bones are very sensitive. Bones are very innervated and they are very irrigated. Uh, when we look at bones, we have arteries that will come to the bone. The arteries, they can be what we call the periosteal arteries. They're arteries that are going to ramify in the periosteum. And we have the medullary arteries. Those are the arteries that are going to come to the nutrient forming and go inside of the cancellous bone. Right? So we have uh, different types of uh, arterial supply to the bones, right? And we also have nerve fibers that will accompany those blood vessels, right, inside here, uh, inside of those bones, and those nerves. They will work as proprioceptors, determining the position of the joint angle, and also horses know, so animals know, their their body positioning based on those receptors, those proprioceptors, and also, I mean, they're gonna have sensory receptors. They're gonna so they allow a horse to feel pain or to uh, identify when something is not going right. We're gonna talk about receptors and all that stuff later on. But for now, we need to understand the types of skeleton. We need to understand the different types of bones. Now we have long bones, we have flat bones, we have irregular bones, we have sesamoid bones, and we have short bones. Uh, we saw that every bone has an outside layer that's called the cortical bone is a compact bone, right? Which the main function is to protect, is to provide the rigidity to the bone. And on the inside, they have another type of substance called the cancellous bone. And the cancellous bone, uh, it is responsible the for It's filled with bone marrow, and this bone marrow can be red bone marrow, yellow bone marrow. Yellow bone marrow is related to adipose tissue, it's pretty much fat. The red bone marrow, the production of blood cells. As the animal ages, the red blood marrow is replaced by yellow blood marrow. Um, we also saw the parts of the bone, the parts of a long bone. We have your diaphysis, which is your shaft. We have the epiphysis, they are the end of the bones. The metaphysis, there are the regions in between them. And we saw that bones are constantly changing, and they are very well irrigated and innervated, um, which will allow the horse to have the sensation on the bones and the proprioception abilities. And the irrigation, of course, the arterial supply will allow the bones to grow. Well, thank you very much, and then we will continue next time with the process of bone formation and types of bone cells.